In 2017, Elon Musk promised a 500-mile electric semi starting at $150,000. Production by 2019. It did not happen. Not in 2020. Not in 2022. Not in 2024. The Tesla Semi finally hit mass production in March 2026 at nearly double the original price. With 50,000 trucks a year now planned and Walmart, FedEx, and UPS on the wait list, the hardest test is just beginning. Spotlights swept across the stage in Hawthorne, California as Elon Musk introduced the Tesla Semi on November 16, 2017. The truck rolled forward under its own power, framed as the start of a new era for heavy vehicles. Musk declared it a Class 8 tractor capable of hauling 80,000 pounds, the maximum allowed on American highways. The headline figure was impossible to ignore: a 500-mile range on a single charge, even at full weight. Acceleration numbers bordered on science fiction. Tesla claimed 0 to 60 miles per hour in under 2 seconds when empty, 5 seconds with a trailer, and 20 seconds fully loaded. Pricing was just as bold: $150,000 for a 300-mile version, $180,000 for the 500-mile model. These numbers undercut diesel competitors and rivaled the cost of a typical Class 8 tractor, a move intended to shake the entire freight industry. Musk promised a network of solar-powered megachargers able to add 400 miles of range in 30 minutes, a claim that implied a leap in charging technology. The cab design featured a center-mounted driver's seat, no exterior mirrors, and a digital dash, signaling a break with traditional truck interiors. But amid the spectacle, technical details were thin. No battery pack size, no motor architecture, and no explanation of how such range could be achieved at legal weight. Industry analysts immediately questioned whether the physics of battery energy density could deliver on these numbers. For now, the promise stood as a challenge to every established truck maker, and as a bet that Tesla could turn ambition into hardware. Tesla's original production target for the Semi was set for 2019, a date repeated in press releases and earnings calls throughout 2018. But when 2019 arrived, the truck remained in development. On the first quarter 2019 earnings call, Tesla officially moved the launch to 2020, citing a shortage of Panasonic 2170 battery cells. The Semi's battery pack required 5 times more cells than a Model 3, and with Model 3 and Model Y production ramping up, there simply were not enough cells to go around. As the months passed, the timeline slipped again. In early 2020, the COVID-19 pandemic forced battery plants in Fremont and Nevada to shut down, deepening the bottleneck. Development of Tesla's next-generation 4680 cell, announced at Battery Day in September 2020, also lagged behind schedule. Pilot production of the 4680 did not begin until 2022, and cell yields remained too low for mass production. Musk and Tesla executives pointed to these supply issues again and again, explaining that until the new battery line stabilized, the Semi would stay in low-volume pilot mode. Behind the scenes, engineering teams struggled to adapt the truck's design to evolving battery chemistries, while manufacturing planners tried to align factory readiness with the unpredictable pace of cell development. By 2023, the Semi's production window had been pushed to 2024, then again to 2025, as Tesla worked through both technical and regulatory hurdles. What began as a bold timeline became a public test of Tesla's ability to deliver on its most ambitious promises, a challenge that would define the Semi's reputation for years. PepsiCo became the proving ground for the Tesla Semi in December 2022. The first handover took place at Tesla's Nevada site, where 2 trucks, finished in Frito-Lay livery, rolled into service after years of anticipation. Those were not showpieces. They were assigned to real routes, hauling loads between PepsiCo's Sacramento distribution center and regional customers. Over the following months, the pilot fleet grew to around 21 units, with plans to reach 50 across California. The trucks operated under daily freight demands, logging miles and collecting data that would matter far more than any stage presentation. Operational reports from the field began to circulate. Energy use landed between 1.5 and 1.9 kilowatt hours per mile, depending on the route and load, numbers that placed the Semi in a competitive spot against diesel rigs. At electricity rates near 9 cents per kilowatt hour, the fuel savings stacked up quickly, promising annual reductions in operating costs that appealed to fleet managers. But these were still pilot units, not mass-market trucks. PepsiCo's experience offered the first real test of whether Tesla's electric hauler could meet the relentless pace of commercial logistics, not just the hype of its reveal. By 2026, the Tesla Semi stands as a production-ready machine shaped by years of engineering trade-offs and regulatory hurdles. The truck now comes in two distinct variants, a standard range model rated at 325 miles and a long-range version that can reach 500 miles, both at a gross vehicle weight of 82,000 pounds. Under the cab, Tesla settled on a tri-motor architecture, 3 independent electric motors on the rear axles, delivering a combined 800 kilowatts or roughly 1,070 horsepower. This setup replaces the original 4-motor concept, balancing performance with manufacturability. Charging capability has moved from a bold idea to a requirement. The long-range Semi supports up to 1.2 megawatts at dedicated megacharger stations, while the standard version accepts around 800 kilowatts. Pricing has tracked upward, with the long-range variant quoted to customers at $290,000, reflecting the cost of the high-capacity 4680 battery pack and advanced power electronics. Tesla describes both trims as designed for autonomy, keeping the promise of future self-driving capability on the table. What remains is a truck that preserves much of the original mission: long-haul range, rapid charging, and lower operating costs, while absorbing the realities of scale production and the limits of current battery technology. Construction began on Tesla's dedicated Semi factory in Sparks, Nevada in early 2024, signaling a new phase for the electric truck program. The site covers 1.7 million square feet, a footprint large enough to house every stage of manufacturing, from chassis stamping to battery pack assembly and final inspection. By January 2025, the factory reached a major milestone. The exterior walls and full-height roof were in place, making the building weather-tight and ready for the next stage. Inside, installation of high-speed stamping presses, battery pack lines, and autonomous material handling systems started in the first quarter of 2025. The plant's location is no accident. It sits directly adjacent to Gigafactory Nevada, allowing battery cells and powertrain components to move straight from one facility to the next without cross-country shipping. This proximity is designed to streamline logistics, cut lead times, and keep production costs under control. Rather than a design studio or pilot shop, the Reno facility stands as evidence of Tesla's commitment to large-scale, repeatable manufacturing. Every square foot is engineered for volume, setting the stage for the Semi to move from prototype to product line. On April 29, 2026, the first Tesla Semi rolled off the high-volume production line at the Reno factory. After years of pilot builds and limited runs, Tesla crossed into serial manufacturing. This moment was not greeted with a spectacle or sweeping declarations, but with the quiet confirmation that mass production had begun. The Reno facility, built for scale, now delivered a finished truck ready for commercial shipment. Years of delays and redesigns gave way to a single, tangible result: a production Semi, assembled not as a prototype, but as part of a repeatable process. The promise had finally become execution. Tesla's stated goal of producing 50,000 Semis per year sets an entirely new bar for what an electric truck program means. At that scale, Tesla would instantly join the ranks of North America's largest Class 8 manufacturers, companies that have spent decades building out supply chains, dealer networks, and service operations. For context, Freightliner and Peterbilt each deliver similar volumes annually, but they do so with mature, highly automated plants and established logistics. The difference now is not about who has the flashiest prototype, but who can deliver trucks by the thousands, month after month. Throughput, how many finished vehicles actually make it out the door, becomes the real test of Tesla's promise to disrupt the heavy trucking industry. Fleet buyers now hold the keys to the Tesla Semi's future. Companies like Walmart, FedEx, UPS, and Cisco have all placed reservations, turning the order book into a public scoreboard for Tesla's credibility. By early 2026, at least 180 confirmed units sit in the backlog, with industry trackers estimating several hundred more reserved. This demand is not theoretical. These are the world's largest freight operators, accustomed to precise delivery schedules and relentless uptime. For Tesla, the challenge has shifted. It's no longer about building a few headline-grabbing trucks or impressing pilot customers. Now the task is to deliver vehicles in steady, predictable batches, month after month. Clearing the backlog isn't just a matter of production speed, it's about consistency, reliability, and the ability to meet the cadence expected by commercial fleets. As 2027 approaches, every missed delivery or delay will be measured not in headlines, but in lost confidence from the companies that move America's goods. Now, as Tesla aims to produce 50,000 electric semis a year, the freight industry faces a test of both ambition and infrastructure. Success hinges not just on engineering, but on whether the world is truly ready to rethink how goods move. The future of trucking is finally up for grabs.